Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals. In this presentation, we will be solving problems using the rules of integration. Let's look at some examples. This example is using a polynomial and a radical function. If we have to evaluate an indefinite integral as shown here, integral x to the power of 2 minus 3 over 2 square root of x plus x to the power of minus 4 over 3 dx, we can solve it by integrating each one of these functions separately, as shown here. Integral x squared dx minus integral 3 over 2 minus 3 over 2 integral square root of x dx plus integral x to the power of minus 4 over 3 dx. Now, we want to convert the radical terms into exponential terms before we start to use the power rule. So square root of x can be written out as x to the power of half, as you can see in this step here. So y is equal to integral x squared dx minus 3 over 2. Since 3 over 2 is a constant term, we have taken that outside of the integration sign. Integral x to the power of 1 half dx. So instead of square root of x, we have now written it as x to the power of 1 half. And then the third part of the problem is x to the power of negative 1 over negative 4 over 3. We can write that as integral x to the power of minus 4 over 3 dx. This combined function, we are separating it out into different parts and then integrating them separately. Okay. Now, we're going to use the power rule for the first part, for the second part, and the third part of the problem. So integral x squared dx, when we integrate that using the power rule, it simplifies as shown here. X to the power of 2 plus 1 divided by 2 plus 1 minus 3 over 2 is on the side. Integral x to the power of half dx we can write as x to the power of 1 half plus 1, the whole thing divided by 1 half plus 1, plus integral x to the power of negative 4 over 3 dx. When we simplify that using the power rule, we can write it out as shown here. X to the power of minus 4 over 3 plus 1 divided by 4 over 3 plus 1 plus c. C is the constant of integration. So when we simplify it, it's going to look like as shown in this next step here. X to the power of 2 plus 1 is x to the power of 3 divided by 2 plus 1 is 3, that is in the denominator, minus 3 over 2, x to the power of 1 half plus 1. When we simplify the fraction and the whole number, 1 half plus 1 is equal to 3 over 2, x to the power of 3 over 2 divided by 1 half plus 1 in the denominator converts to or simplifies to 3 over 2, plus x to the power of minus 4 over 3 plus 1, minus 4 over 3 plus 1 simplifies to x to the power of minus 1 over 3, and in the denominator 4 minus 4 over 3 plus 1 simplifies to minus 1 over 3 plus c. So when we simplify that some more, it looks like this. X to the power of 3 divided by 3 minus 3 over 2, and then we have 3 over 2 in the denominator. When we bring it to the side of the equation, the denominator, the fraction is going to flip, and we can write it as 2 over 3, x to the power of 3 over 2, the remainder there, minus, in the denominator, we have negative 1 over 3, and we have a positive sign here. Positive divided by a negative is going to be a negative, and 1 over 3, when it flips over, is going to look like 3 over 1, and then we have x to the power of negative 1 over 3 plus c. Then we can simplify it some more. X cubed divided by 3 minus 3 times 2 divided by 2 times 3, x to the power of 3 over 2. We can simplify it some more, and I'm going to show that in the next step. Minus 3 over 1 is equal to 3. And then the negative exponent, we can express that as a positive exponent by bringing it to the denominator, and we can write it as 1 over x to the power of 1 over 3 plus c. So when we simplify it some more, it's going to look like this. X to the power of 3 divided by 3 minus 3 times 2 is 6. And then in the denominator, we have 2 times 3, which is also 6. 6 divided by 6 is equal to 1. So we did not write the 1. So 1s are implied. The coefficient 1 is implied. So we're not going to write that. So the rest of the equation is x to the power of 3 over 2 minus 3 divided by x to the power of 1 over 3 plus c. So this is our solution. This is our solution. So where c is the constant of integration. As we mentioned before, whenever we complete the integration process, we're going to add a constant c to the solution part. Let's look at the next example. In this example, if we have to integrate this particular polynomial, we have x to the power of 4 plus 1 over 8 times square root of x minus 4 over 5 x to the power of minus 2 over 5 dx. So this polynomial function, we can integrate each one of these functions separately as shown here. We can write this one as integral x to the power of 4 dx plus 1 over 8. Since 1 over 8 is a constant, we're going to take that outside of the radical term, and then integral 1 over square root of x dx minus, since 4 over 5 is a constant, we're going to write that outside of the integral term as shown here, times x to the power of minus 2 over 5 dx. Now, we want to convert the radical terms to exponential terms and then be able to simplify it from that point on. We want to convert them into exponential form because then from that point on, we can use the power rule. So square root of x, we know that square root of x is equal to x to the power of half. The radical terms can be converted to exponential terms as shown here. So in the next step here, we're going to write this radical term as an exponent. Y is equal to integral x to the power of 4 dx plus 1 over 8 integral x to the power of minus 1 half dx. What did I do here? Square root of x is equal to x to the power of half, but that is in the denominator. If we have to bring it to the numerator, we can write that as x to the power of minus 1 half. The positive exponent in the denominator, when we bring it over to the numerator, we can express that as a negative term, and as shown here, 1 over 8 integral x to the power of minus 1 half dx minus 4 over 5 integral x to the power of minus 2 over 5 dx. Now we have everything in the form of the power rule, and now we can apply the power rule for each one of these integrals separately. When we perform the power rule for each of these, it simplifies as shown here. X to the power of 4 plus 1 divided by 4 plus 1 plus 1 over 8 x to the power of minus 1 half plus 1 divided by 1 half plus 1 minus 4 over 5 x to the power of minus 2 over 5 plus 1 divided by minus 2 over 5 plus 1 plus c. So when we simplify it, it's going to simplify as shown here. X to the power of 5 divided by 5 plus 1 over 8 x to the power of minus 1 half plus 1 simplifies to plus 1 half divided by plus 1 half minus 4 over 5 x to the power of minus 2 over 5 plus 1 simplifies to x to the power of 3 over 5 divided by 3 over 5 plus c. So when we simplify it some more, x to the power of 5 divided by 5 plus 1 over 8 times the denominator 1 over 2 flips over as 2 over 1 times x to the power of 1 half minus 4 over 5. The 3 over 5 in the denominator here, we can write it out as 5 over 3 by the side of this equation times x to the power of 3 over 5 plus c. So when we simplify it some more, it's going to look like this. X to the power of 5 divided by 5 plus 1 over 4. 2 is in the numerator, 8 is in the denominator. So when we simplify it, it's going to be 1 over 4 x to the power of 1 half minus, we have the 5s and 5s cancels out, and we have 4 over 3 x to the power of 3 over 5 plus c, where c is the constant of integration. So this is how we're going to use the power rule to solve simple example problems. In my next video presentation, we will be solving problems using the power rule, using the rules of exponents.